Okay, this is an first video for explaining cubic functions and calculus and what we have to do with it. Now, this little outline here by Mr. Autry at our school is really useful. There's actually 5 steps to dealing with the cubic equation, 5 things you need to know about. The first thing is the shape of the cubic equation. And this is the standard form. You've got x cubed, you've got x squared, you've got x, and you've got a number. B, C, and D could be 0, and you could just have something x cubed. But if A is a negative number, then this is the shape. You end up with 2 curves like this. It looks like 2 parabolas, but it goes down at the end if A is a negative number. If A is positive, it looks like there's 2 curves here, but it goes up. If A is a positive, this is the shape. And to find a y-intercept, like all functions, you let x equal 0, and so y equals d is the y-intercept. But to find the x-intercept, you let y equal 0, and you have this cubic equation, and you have to solve for it. And there's this process called using the factor theorem. You look for one number that might make this 0, and it's a factor of d, and you start with 1 or minus 1, and any numbers, small numbers that go into d, you try it, and if you find one that makes it 0, then x minus that number is a factor, and you can put a bracket down, and that's how you get started. For stationary points, sometimes called turning points, what you do is you find the derivative. You find the derivative of the function, and you make it equal 0, because where the derivative is all about the gradient. And where the gradients are 0, that's where you have a stationary point. That's where it turns, right at the bottom or the top of the curve. So you make f prime of x equal to 0, and then you solve it. Usually get 2 turning points. And the last thing is called a point of inflection. You take the derivative of the derivative, and you make it equal 0, and that gives you the inflection point. And what does it tell you about? It tells you about concavity. This is concave up when it's shaped like this, and this is concave down. And the point where it changes is called the inflection point. So to the right of the x value of the inflection point, it's concave down here. And to the left of the x value of the inflection point, it's concave up. Oh, here it's concave up from the inflection point to the right, and to the left, it's concave down. So second derivatives tell you all about concavity. And if you do have x values for stationary points and inflection points, if you want the y values, you always go back to the original function. And that's how you do it. So that's our introduction.